Welcome back, grades 7 and 8. Now that we've talked a little bit about reflection and how reflection is light hitting an object and bouncing off of it, whether it be a regular, smooth, or plain object, um, or whether it be a very curved object, we're now going to talk about something called refraction. Well, we know that reflection occurs when light rays bounce off objects, and we can accurately predict the direction in which reflected light rays travel by using what we call the law of reflection, which was that the angle of reflection equals the angle of incidence, and we can be able to measure that out and predict how that's going to work. Well, we can also predict where an image will be located on a plane mirror. Right? We talked about how we can predict that there will be an image that appears kind of behind the mirror, even though it's bouncing off and it's coming from a different location. But what happens when light moves from air into a medium such as water, where it can still pass through? Well, if you've ever stood on the side of a pool and tried to dive for an object on the bottom, you may have been surprised that the object was not where you expected it to be. And that's because of refraction. Refraction is the bending of light when it travels from one medium to another. A medium is something like air compared to water. When it goes from, or even it could be from cold air to warm air. As it travels through, light is going to travel at different speeds. And so it's either going to speed up and change direction a little bit or slow down and change direction a little bit. Light bends because it changes speed when it moves between materials that have different densities. Light usually travels more slowly in comparatively dense materials where the molecules are more closely compact. The bending of light makes the object's image appear to be in a different position from where the object really is. For example, if we are taking a look into a water and we're trying to see where a fish might be, well, where the fish appears to be to us is not where it's actually going to be. If you've ever tried to catch something that's in the water, you know that when your hand goes in it, it's not actually where you think it looked like it was supposed to appear. And that's because where we see the fish to be and where it actually is are two very different places, because the bending of light allows us to see that object in a different spot than where it really is. Okay, so let's try to understand this a little bit more. Well, when light travels from one medium into a denser one, for example, when it moves from air into water, water would be more dense than air, more tightly compact molecules, it will bend toward the normal. Now, this diagram might look really, really complex, but what it's really showing is a light ray traveling from a less dense material. Let's just think about that as air, for example, into something that's more dense. Let's think of that as water, for example, and then back out into something that's less dense again. And what it shows here is that as it moves from a less dense air into more dense water, we still know that the incident ray, which is the ray that's coming in, wherever it hits an object, and this was the same for our mirror, it creates this perpendicular line called the normal. And if it was a mirror, it would reflect off at that exact same angle. But because it's not, it can go through it. It's a transparent material. We're going to have a change in direction continuing here. And when it's going from less dense to more dense, it's going to slow down slightly and it's going to move more toward this normal line. When light exits a denser material, its direction of travel bends away from that normal line, so it speeds up as it kind of comes out of the water into the air. So then, where we see the light coming in here, the light bends and actually comes out here, we can see how there can be a displacement or a change in where something might appear versus where something actually is. Because we're looking this way along this line, but it's actually on this line here, which causes us to see it in a different location. How much bending occurs depends on the type of material through which the light travels. The new direction of the light is called the angle of refraction, right? Instead of the angle of reflection, like we talked about with reflection, this is the angle of refraction. Makes sense. When the angle of incidence, I, just like we had before, increases, the angle of refraction also increases. However, doubling the angle of incidence doesn't necessarily mean that the angle of refraction also doubles. It's a little bit more complex as we're going through different materials that way. Refraction can also occur when light travels through air at different temperatures. So, different temperature air is actually more or less dense. Warm air, for example, is less dense than cooler air. So, light bends as it travels through different densities of air. The refraction of light through air can result in what we call a mirage. Have you ever been driving along on a hot summer day and notice that it looks like there are pools of water lying ahead of you? However, when you get close to those pools, they mysteriously disappear. Well, you're actually seeing what's called a mirage. And that shimmering that looks like water is really the refracted light. What it's doing is it's traveling and it's hitting the less dense air, which is the hot road in front of you, and it's refracting up into the sky. And as it's doing that, you are actually seeing the sky in the road because of that bending of light. It's a really weird thing, but it causes us to kind of think like it's water, but in reality, we're just seeing the refraction into the sky because the light is traveling through something that's less dense, the hot air right above the road. The air closer to the ground is hotter and less dense than the air higher up, and as a result, light from the sky directed at the ground is bent upwards as it enters the less dense air. And so the pools of water were actually images of the sky refracted by warm air near the ground. So, is that all there is to light? Well, let's take a look at another chart here. It's a bit of a complex chart, and so let me unpack it for you. This talks about what happens to light when it strikes different surfaces. Sometimes all three behaviors could happen at once. Light from the sun, for example, can reflect off the still surface of a lake to produce a mirror-like reflection, while at the same time, the water can absorb light, transforming the light energy into thermal energy. The water warms during the day and cools off at night, so if you're looking down into the water from shore, you might be uncertain about the location of objects on the bottom. This happens because light is refracted as it travels from water into the air. So if we're talking about absorption, absorption is when it changes into some other kind of energy, whether that be, usually that might be like thermal energy, for example. In other words, when light hits an object, it gets absorbed, which causes it to get very, very hot. We're going to talk about this a lot more when we're talking about how light works with colors. It's the same reason why if you had a black car compared to if you had a white car, it would get a lot hotter if it was black compared to if it was white, because it's absorbing that light energy and it's releasing it as thermal energy. The nature of the surface, it occurs mostly on rough, dark, or opaque surfaces, or opaque are surfaces you can't see through. So these are a lot of the surfaces that do the majority of the absorbing of some of that light energy. And what else might happen? Well, some light is usually reflected off the surface, otherwise we wouldn't be able to see it. But not as much as a lot of our other ones, not as much as reflection especially, or refraction as well. With reflection, when the light strikes a surface, it bounces off the surface and travels in a new direction using our law of reflection. It occurs best when light hits something that's smooth or shiny. Some light is usually absorbed, but the majority of it usually bounces off and travels in that new direction. With refraction, light travels through the substance, often in a new direction, depending on whether it is more dense or less dense than when it was coming from. This occurs when light strikes a different or a transparent, in other words, you can see through it, medium. What else happens? Well, some light is usually reflected as well. So not all of it gets refracted. Some actually does get reflected back, and some actually might also get absorbed as well. So sometimes all these three things are happening at once. But the primary thing that happens is that it travels through the object, but either slows down or speeds up as it's doing that. So this is kind of a neat thing all about refraction and some of the difference between refraction, reflection, and absorption. In our next video, we're going to start to take a look much more at refraction, but what happens when we don't have refraction through different mediums, but when we start having refraction taking place through different curved objects like lenses. And that's what we're going to be getting into in our next video.